in this video we're going to take a look at discrete probability distributions. And so we are going to use two methods or two pieces of information as we try to calculate things in this section. So one thing we might use is real sample data. If we use real sample data, we're thinking about using methods from chapters 2 and 3 to compile and create relative frequency distributions for each observed outcomes. So then we think about those as the associated probabilities. Or we might use methods from chapter 4 to find the probability for each potential outcome, or possibly even a combination of these two ideas. So those are the two things we'll do, two methods we will use. Right now, let's take a look at some concepts, some definitions associated with probability distributions. So the first thing we have is a random variable. So random variable is a variable, right? So that makes sense. Typically represented by an x. It's a variable that has a single numerical value that's determined by chance. Right? So we'll look at some examples of these, but you might say the number of puppies that a dog has in a litter. Right? We don't know how many that will be. It's kind of determined by chance. That is a random variable. Associated with a random variable, we have a probability distribution. So a probability distribution, this gives the probability for each value of a random variable. We might write this as a table, we might write it as a formula, or we could represent it as a graph. With random variables, there are two different types of random variables. These types of random variables will correspond to the types of data that we've seen previously. So we have a discrete random variable. This has a collection of values that is finite or countable. So something like the number of puppies in a litter. I usually think of this as a counting process. The other type of random variable we have is a continuous random variable. This has a collection of values that's infinite and is not countable. I tend to think of this as a measuring process. So the, amount of milk a cow produces. Right, so that you would measure the amount of milk. There's an infinite number of values, even if there's a cap. When you go to exact precision, there's an infinite number of values that could possibly show up. And so that would be an example of a continuous random variable. All right, so let's look at some examples. Determine whether each is discrete or continuous, or if it's a random variable at all. So the number of eggs laid by a sea turtle in 1 year. That is a random variable. It's a discrete random variable because you would count the number of eggs. The color of a person's eyes is not a random variable because it needs to be a single numerical value, and the eye color is not a numerical value. Oh, the precise amount of milk that a cow produces in fluid ounces, we actually already talked about that. That is a continuous random variable. All right, so that's what random variables are, and the types of random variables. We can associate with these random variables probability distributions. So with a probability distribution, some properties, we would have a discrete random variable, x, and its values are associated with corresponding probabilities. If we add up all of the probabilities, so that's what that right here means. So that is the sum of, we're adding up all the probabilities. When you add up all of the probabilities, it should add up to 1. You could have values that are really close to 1, but not quite 1, that could show up because of rounding error. So if you have some that's like 0.99 or a little bit more than 1, that could possibly happen because of rounding error. In general, excluding rounding error, if everything was done to exact precision, it should add up to exactly 1. Each individual probability should be between 0 and 1, so we can't have a negative probability. We could have a probability equal to 0. We can't have any probabilities larger than 1. All right, so let's look at this example here. Which of the following is a valid probability distribution? So let's look at this right here. Actually, let me do it this way. Let's look at this right here. So is this a probability distribution? So we need to see, do we have a discrete random variable x and values associated with it are probabilities? So here are the random variable x. There are 4 outcomes, 0, 1, 2, and 3. Here are probabilities. So that looks maybe okay. Do the probabilities add up to 1? So if we add all of these up, 0.4, 5, 6, 7, these all add up to 0.80. So that is not a probability distribution, because when we add all of those up, they should add up to 1. Let's look at the next one. Here we have, when we look at this, these values right here, we have 4 different values associated with some probabilities. If you add all of those probabilities up, those values up, they do add up to 1. However, this last statement here says all of those values should actually be individual probabilities, so they should be between 0 and 1. And down here we have a value that is negative. That negative value says, nope, this is not a probability distribution. And here, this final one, they add up to 1. All of those are okay. And so, yes, this one is a probability distribution. In our next video, we'll look at formulas, so ways we can use a probability distribution and calculate things like mean and standard deviation and variance. We will see you there.